Assalamu alaikum, my dear students. How are you? Hope all of you are well by the grace of Almighty Allah. Welcome to NIEBS Home School. This is Shahjadi Akter, Assistant Teacher of Science of National Ideal English Version School, Day Shift. Today I am going to take a physics class for class 9 students. My dear students, our today's topic chapter 7, CQ 1 and 2. Our today's lecture number 26 and HW number 23. My dear students, let's start our class. This is from chapter 7, CQ 1. Our today's topic CQ 2 and 3. CQ 2 and 3. At first we will discuss CQ 2. Using the information given below and based on figure 1, answer the following questions. My dear students, this is the stem, this is the figure of wall. This is a wall. Here given frequency of sound 1200 Hertz and air temperature is 30 degrees centigrade, and this is the distance from this distance S, and this is the sound source. S is sound source, and from here, from sound source to this wall, distance is 18 meter. Now question A, what is periodic motion? Question B, why is water wave a transverse wave? Explain. Number C, find the wavelength of sound, and number D, is it possible to hear echo at position S? Verify the mathematical logic. My dear students, number A question is what is periodic motion, and you have already learned this definition in our previous chapter. Okay. Now number B, why is water wave a transverse wave? Explain. Answer. Transverse wave indicates that the direction of motion of the particles is perpendicular to the direction of propagation of the wave. My dear students, at first we have to give the definition of transverse wave. Transverse wave indicates that the direction of motion of particles is perpendicular to the direction of propagation of wave, and water wave is transverse wave because the direction of motion of the particles of water is perpendicular to the direction of the propagation of the waves of water. Okay, that's why transverse water wave is a transverse wave. Now number C, find the wavelength of sound. My dear students, at first you have to write what is the given. Here given the frequency of sound, frequency F, we indicated frequency by F equals to 1200 Hertz. Temperature is 30 degree, here given 30 degree, and velocity V, wavelength, we have to find out the wavelength, and wavelength is lambda watt. So at first we have to write, we know the velocity of sound air at a temperature of 0 degree is 332 meter per second, and it is increasing by 0.6 meter per second with an increase in temperature by 1 degree centigrade. So velocity of sound in air at a temperature of 30 degree centigrade is, it will be velocity, it will be 332 meter per second plus 0.6 meter per second into 30. Okay, so 332 plus 18 meter per second, that means 350 meter per second. Velocity will be 350 meter per second. And next we have to find out the wavelength. So we will write this formula, V equals to F lambda. We know V equals to F lambda. So lambda equals to V divided by F. Here V means velocity of sound is 350, and frequency here given 1200. So by doing this calculation we will get 0.2917 meter. Okay, this is the wavelength. This is the wavelength of this sound. Okay, now come to number D. Is it possible to hear echo at position S? Verify the mathematical logic. My dear students, see, it says 18 meter, echo cannot be heard. Okay, it says 18 meter, echo cannot be heard, but if it is distance ranges up to 18 meter, echo can be heard. We have already found out then velocity of sound in air at temperature of 30 degrees centigrade is 350 meter per second. So since an echo implies twice the distance between the source of the sound and the reflector, we know the distance is, this is the formula, V equals to 2D by T. Okay, then 2D equals to Vt, so D equals to Vt by 2. By using this formula we will find out the distance. Here velocity given 350 meter per second and time t equals to 0.1 second. My dear students, this is the minimum time for taking place echo. This is the minimum time for taking place echo. So we can find out D equals to Vt divided by 2. This is the distance of the formula. Okay, D equals to Vt divided by 2. So here V equals to 350 into T is 0.1 second. This is the minimum time for taking place echo and divided by 2. Then we will find 17.5 meter. Distance is 17.5 meter. So this distance is less than the distance between the source and reflector. Here given the distance, see this figure, here given the distance is 18 meter from sound source to this wall is 18 meters. So now we will find 17.5 meter distance. So this distance is less than the distance between the source and reflector. It is therefore possible to hear echo at position S. Okay, that means this sound can to hear echo this position at point S. Now question number, come to CQ number 3. During summer vacation, Nusrat visited Shahjadi with her family. To hear an echo, she screamed loudly beside a hill, but hearing no echo, she felt sad. Then her father told Nusrat to move 3 meter and to make sound. This time Nusrat heard the echo. On that day, the velocity and frequency of sound was 332 meter per second and 1328 hertz. Now come to question number A. What is echo? What is echo? Then question number, my dear students, you have already learned this definition from our previous class. Now question number B. Why is a minimum distance necessary to hear echo? Answer will be, when we hear something, the feeling persists for around 0.1 second. So to hear two sounds separately, it needs separation of 0.1 second difference between two sounds. As the velocity of sound at 0 degree centigrade is 332 meter per second, to create the difference of 0.1 second, sound has to travel 332 into 0.1. That means 33.2 meter. So the minimum distance of the source from the reflecting surface is 32 divided by T. Okay, that means divided by 2. Okay, we know this formula, D equals to Vt, D equals to Vt divided by 2. Okay, so 33.2 divided by 2, that means 16.6 meter. Okay, and now come to number C. What is the wavelength of sound produced by Nusrat? What is the wavelength by sound? That means we have to find out the wavelength. My dear students, now given the velocity of sound, here given the velocity of sound, we'll solve number C now. Velocity of sound given V equals to 332 meter per second. Frequency also given 1328 hertz, and we have to find out the lambda. So V equals to F lambda. By using this formula we can easily find out lambda equals to V divided by F. So V equals to 332 divided by F means 1328. So it will be 0.25 meters. So this is the wavelength. Okay, this is the exact wavelength. Now come to number C, number D. How far does Nusrat have to move backward if she want to hear an echo after 0.3 second of screaming? My dear students, the question number D answer is, we know the minimum distance required between the source and the reflecting surface to hear echo is 16.6 meter. If the velocity of sound is 332 meter per second, in order to hear echo after 0.3 second, let the distance is d. So this distance will be d. So here given velocity v equals to 332 meter per second and time t equals to 0.3 second. Okay, so v equals to 2d by t. By using this formula, we can easily find out this distance will be 2d equals to vt. That means d equals to vt divided by 2. Now put this value, v means 332 into 0.3 divided by 2. That means 49.8 meter. The distance 49.8 meter. So the distance Nusrat needs to move backward. We have to subtract this from this 49.8 meter minus 16.6 meter. So we find out 33.2 meter. The distance will be Nusrat have to move backward 33.2 meter. My dear students, now I am giving you SW. This SW is for your Ramadan vacation. Of Eid ul Fitr. Okay, your SW will be chapter 7, CQ 2, 3, C and D. Okay, CQ 2, 3, C and D, and you have to submit. Submission date will be 29/5/21. Okay, my dear students, I hope all of you have understood this topic, memorize properly this CQ and practice at home, and you have to submit this SW on 29/5/21. Okay, see you again in the next class. Allah Hafiz.